In this video we'll discuss LP norms, and it is very popularly used with regularizers. So let's say you have a theta in a d-dimensional space, which could be something like this, right? You have a vector of theta 1, theta 2, up to theta d. So you have a d-dimensional vector theta, and you're trying to define a norm. So one example is L1 norm. L1 norm, and what it is basically how you write it is like this, and what it is actually is sum over all I, absolute value of theta I. So your sum over all theta I is absolute value, right? So it would be like absolute value of theta 1 plus absolute value of theta 2 plus absolute value of theta 3 up to absolute value of theta d, right? Now similarly, L2 norm you can define as this. So what it is basically is the square root of sum over all I theta I square, right? And then what it basically is will be square root of theta 1 square plus theta 2 square plus theta 3 square up to theta d square, right? And then finally LP norm, which is again written as this, and what it basically is you sum over all i's theta to the power p to the power 1 by p, right? So L1 norm and L2 norm are the most popular ones, and how you will usually use it will be maybe one would be like this r of theta could be lambda times L1 norm of theta, or it could be lambda times L2 norm squared of theta, and you could have a combination of it like lambda 1 and lambda 2 sum of it, right? So there are multiple variants of it, and those will behave in a very different way, and the mix will behave in a different way, and we'll discuss those in the next videos. Yeah.